The lesson topic for this video is graphing radical functions, square roots. So what you see here, f of x equals the square root of x, is the square root parent function. So if we change this function a little bit in ways that you're going to see in the next page or slide, they're all kind of based on this original function, just the square root of x. So we're going to graph this first by using a table. Okay, because we can always graph any function by filling in values with the table. So we're going to start by taking 0 and putting it in for x, and we're going to find the output, and the output is our y value or our f of x, and if we're using function notation. So we're going to start by saying, f of 0, right? We're going to put 0 in for x. So f of 0 equals the square root of, whoops, I was going to put x there, 0, and the square root of 0 is 0. All right, we'll start with our second one here, f of 1, and that means we're going to take the square root of 1. Well, the square root of 1 is 1. F of 4 means we're going to take the square root of 4, and the square root of 4 is 2. And then we have f of 9. F of 9 is the square root of 9, which is 3. And then the last one we're going to throw out there is f of negative 1. F of negative 1 is the square root of negative 1, and the square root of negative 1 is, well, I, right? So we can't graph I, we can't graph an imaginary number, so we're actually not going to use that one. Okay? And that's going to tell us a little something about our graph later. All right, so the first point is 0, 0, which is right here. Our second point that we got is 1, 1, so 1, 1 is here. Then we've got 4, 2. So right 4 on the x-axis and up 2, which is right here. And then we've got 9, 3. So 9 on the x-axis, 3 on the y, which is right here. So with those points, we can see that the general movement of this graph is curving up and to the right, like so. Notice that we said negative 1 didn't work, right? Because we get into the imaginary numbers, which means that if we went left on the x-axis to negative 1, we wouldn't plot any point, any y value here because it's imaginary. So there are no points on the left-hand side of the y-axis. Later in this unit, when we talk about domain and range of this function, that will be an important thing to think about, is that we do not go left of the y-axis for this function. Okay, so as I mentioned on the previous screen, now we're going to look at some transformations of the square root parent function. So instead of just having, the square root of x, now we've got all of this other stuff going on. So the function that we're going to graph next is, we're going to graph the function f of x equals negative 2 times the square root of x minus 3 plus 7. Now I want to point out to you that the square root does end right here after the 3. This part is not under the root. Now we could create a table and plug values in for x and find the outputs and plot the points. But instead, I'm going to show you a shortcut for graphing square root functions. First of all, if you remember on the previous screen, the first graph went like this, right? So a square root graph is always going to curve either up and to the right like this, or up and to the left, or down and to the right, or down and to the left. Okay, those are the 4 different ways that the square root function can curve. So how do we determine if it curves up and right, up and left, down and right, or down and left? Well, that is going to be determined by what is shown with these 2 arrows here. And that is if a, the number in front of the square root, is positive, then it's going to open or curve up. If a is negative, it's going to curve down. Then, if the number in front, I should say, if the symbol in front of our x minus h situation, so the symbol that's at the beginning of the square root, and we're going to talk more about that in a little bit, there's a symbol going to be in here, positive or negative, and again, positive is going to mean right, and negative is going to mean left. All right, so it's pretty simple. If you see a negative value out here, which we do, -2, we know it's going to go down. It's going to curve down. And then in front of the x here is positive. There's no negative symbol. Then we know it's going to go right. So we know this graph is going to go down and right for this function here. All right, so down and right, but from where? Well, we need to know our starting point, and that is what h and k can help us find, okay? Our starting point. All right, so because the equation in general is right here, okay, the minus sign that is in the square root, x minus h, since the original problem has a minus in here, this minus, that means, is already covered by this subtraction symbol, if you know what I mean here, right? This is showing up here. So then what is our h value in this equation? It is 3. Okay, so h is 3. And what is k? Well, the positive shows up here, so k is 7. Our starting point is h, comma, k. So for this equation up here, this specific example, our starting point is going to be 3, comma, 7. And we've seen this before in this course, that sometimes the number is what it seems like it should be, and sometimes the number is the opposite of what it seems like it should be. And what I mean by that is if you were just looking at this equation, you might think h should be -3, but it's not. It is just +3. So if there's a minus here, it's going to be +3. If there was if there's a positive here, this would be a -3. But then when it comes to this number outside the root, it is what it looks like. Okay, so let's go back up here for a second. We did determine, because this is a negative, that it's going to be curving down. And because the number, the value in front of x is positive, it's going to be curving right. So this graph is going to go down and right from 3, 7. So let's go ahead and plot the point 3, 7. 3, 7 is right here. And now this is going to curve down and to the right with that same kind of curve that I was showing earlier. So down and right. It's going to curve something like this. What I want to point out is that square root functions look like a half of a parabola on its side. Okay, so if you picture a parabola, like we've graphed many times with quadratics, right? But if we turn that on its side, so it's like this, and then we only take half of it, so if I put this point right here and get rid of half of it, that is what our square root function looks like, and that's what I drew right there. Now, when we graph these for this unit, we are just going to be graphing a rough sketch of the curve. We don't know exactly how steep that curve going downward is here. Is it more narrow? Is it more deep? We don't know. So it's just a rough sketch of it. And we could find a point and make it more accurate, but at this point, we're just working on finding that starting point and using the general rule for how it curves. Let's try some more. So once you get used to these patterns, it goes pretty quick. Okay, let's take a look out here. The a value, it doesn't exist, or it does, I should say, but it's a 1. So it's positive, which means this is going to open up. And then the number in front of x, or the sign in front of x, is positive, so it's going to curve right. So this is going to curve up and right. And then we're going to find our h and k value. Now again, if the 4 right there in the root is positive, it's going to be -4 for our x value of our starting point. And then if -8 is outside the root, then -8 stays as -8. So again, the +4 becomes -4, the -8 stays a -8. So let's plot that point, -4, -8, which is right here, -4 and -8. And then we're going to curve up and to the right. And again, when you curve this, please try to make it look like half of a parabola on its side. So we'll curve it up like this, like so. All right, now watch out for this next one. So keep listening, even if you're like, yep, got this, this is easy. All right, watch out for this. So what we need to do here is whenever we have a negative x value, what we need to do is we need to factor that negative out. Okay? In order to use this rule right here, up and right or down and left or whatever it is, we need to factor out the negative. So we're going to always, whenever you see a negative x, you're always going to rewrite your equation. And if you don't, you're going to probably make mistakes with this. It's very common. So we're going to factor out a negative right here, which makes the x positive. And then what happens is it makes this positive 3. We're going to factor out the negative, which makes this negative 3. Okay? And then we have that minus 1, and we're not doing anything with that. And minus 1 stays out there. We're not factoring that out of the negative 1 at all. If you were to think about putting that negative back into the parentheses, we'd get negative x, and then negative 3, which would be positive 3. Now we are ready to graph this. We don't need this anymore. Let's just look at our new equation. So, because this a value is 1 and it's positive, it's going to curve up. And because this up here now is that negative we talked about, it's going to curve left. Our h value now, again from the new equation, if it says negative 3 there, it's going to be a positive 3. And then our k value is negative 1. So we're going to plot a point at 3, negative 1, which is right here. And then we're going to curve up and to the left. And then we're going to make that look like half of a sideways parabola, curving up and to the left. All right. Okay, so we have 2 other quick examples here. What I'm going to ask that you do is pause the video and try these, but please pay attention before you do so. I'd like you to pay attention to right here, the second example with a 7 minus x. So this is the type of example that I'd like you to rewrite 2 times before you graph it. First, I'd like you to rearrange the interior of our square root so that the x is in the front, but make sure you bring that minus sign with it, and then make sure you factor that negative out. So let's see if you can get both of these. Pause the video and then restart it to see if you graph them accurately. Okay, so how did you do on these 2? Again, the first one probably okay, I hope. Second one, rewrite it not just once, but twice. Your point that you start at should be at 7, negative 3, and it should be curving down and to the left.